solving linear inequalities in two variables joined by and or or. Hopefully you're seeing a link to a video or maybe two videos demonstrating when we're dealing with one equation. But here we're going to be graphing more than one equation, two equations to be exact. Now what we're going to do, we're going to graph each line in shade. And once again, you may want to watch that video. That video shows you how to do these with a calculator. And then there may be a second video that shows you how to include some algebra. Just depends. But we're going to graph each line, then we're going to shade the correct region based on if it's less than or greater than. Now with the equations we're going to do today, there's either going to be an and statement or an or statement. Now after we graph each line and shade each region, if it's an and statement, the answer or the solution is where the two regions overlap. If it's an or, then it's everything that's shaded. Now an and is the same as intersection. And or is the same as union. Exact same thing. If you see those, is what they mean. Now another note is if you have an absolute value equation with the less than, that's an and statement. Greater than is an or statement. So what we're going to do, we're going to do some examples. So start the first one. We're going to graph each line. And we're going to graph 2x plus y. We're actually going to graph equals 10, but I'm going to leave it as greater than or equal to 10. Before we can do that, we need to solve for y if we're going to use our calculator, which means we have to subtract 2x from both sides. We get y is greater than or equal to 10 minus 2x. And we're also going to graph y equals 5, but I'm going to leave it as y less than 5. Now since these are both greater than or equals to, or not both, but they both have a equal sign underneath them, the lines are going to be shaded. So let's go ahead and graph each of these. So let's graph y equals 10 minus 2x. Just type it in like you normally would. And graph it. Now it looks like that line. Now I'm going to find 2 points using my table key. And it doesn't matter which two we use, but since these are all going to sevens, negative sevens, let's just use 5, 0 and 4, 2. Now when I graph these, I'm going to use two different colors. So let's graph 5, 0 and 4, 2. It doesn't matter which two you use. Once again, it's a shaded line. So I'm going to shade, try to draw a line that goes through those 2 points. It may be off a little bit, but that's okay. Now watch this on your calculator. If you keep on going to the left and hit enter, that flashing symbol is greater than. This one is less than. Since we're doing greater than, keep on hitting enter till I get back to it. I hit shade, and it's going to shade the right side, or the upper side. It doesn't stop, by the way. It goes on forever and ever and ever. Now watch this. If I go to y equals, and I keep that up there, but I move it over to the equal sign, the cursor, and hit enter, it turns off the graph. Then I hit enter again. It's going to bring it down to y2, and this time we're going to graph y equals 5. Notice it only shows the 5, which is a horizontal line, and if you need to, you can use any of those 2 points, but all it is, it's a horizontal line through y equals 5, which means I'm going to go up to 5 on the y-axis and draw a horizontal line. Once again, to shade it. Since it's less than, we should already know how it looks. You should know that it's going to be below. But let's go ahead and move it over and hit enter until we get to the less than graph. So you can see that it is below. And everything below never stops. Now watch this. Since it's an and, it's where they overlap. What I can do is just go back to y1, go to the equal sign, hit enter, it turns it back on. You see that both now are shaded or darkened. If I hit graph, You can see both of them graphed on the same XY plane. And since it is an and, where the overlap is the answer, so they're overlapping in this darkest region, which is right in here. So the union of the two, the intersection is and, the intersection of the two regions, shaded regions, is the answer. And that's all we're doing. Now let's do the next one. This time we already have them solved for y. But note, since this is greater than, that's less than with no equal sign, these lines are going to be dashed. So what we're going to do first is graph y equals x plus 3. If you hit the table, you will get a couple points, 0, 3, 1, 4. Zero, 3, 1, 4. It's a dashed line. So I'm going to draw a broken line. These lines never stop, so keep that in mind. Now, and once again, if I need to, and you probably do, since it's a greater than, hit enter until you see greater than, hit graph. Tells us we need to shade the upper side. Just do the best you can. And now we're going to graph the OR. Now the OR is x equals 7, but the thing is, I can't graph on this calculator the x equals. So what I'm going to do is just think about it for a second. If y equals is horizontal, then x equals must be vertical. Remember, it's a dashed line. So we're going to draw a vertical line through x equals 7. For x equals 7. Less than means to the left. If you take a number like 4, is 4 less than 7? You say yes. So that means I'm going to shade to the left. Now, what the issue is, it's an OR statement. Since it's an OR, it's the union of the two, which means it takes absolutely everything that's being shaded. So it's all the green and all the blue. Notice how I even went up here because the blue kept on going. So is everything above the blue and everything to the left of the green. So this is the only region that's not shaded. But everything else is. Because the OR takes everything. Just keep that in mind. We're going to do a couple more. Actually, 4 more. Now this first one we're going to do, we have a less than. If you remember less thans, it is an and it has an absolute value, which means we need 2 different equations. Less than and is 2 different equations. There's the and. This is for the positive side. And then we need to do it for the negative side, which means we change the sign and change the sign. So now we're going to solve each one of these. Subtract 2. We get x is less than, or 2x is less than 6, and divide by 2. We get x is less than 3. And come over here, do the same thing. Subtract 2. We get 2x is greater than negative 10. Divide by 2. We get x is greater than negative 5. And the word is and. So what we're going to do, we're going to graph x less than 3. Remember what we just talked about. X equals 3 is a vertical line. Since it's just less than, it's going to be dashed or dotted. Less than is to the left. Now let's do x is greater than negative 5. So let me go back over here and do the green a little bit more. Oh, wrong one. We want to be consistent with our colors. Now let's do greater than negative 5. Negative 5 is over here. Still just greater than, not equals to it. So make sure you have a dashed line. Greater than is to the right on these. So it means we're going to go all the way to the right. Now since it's and, it is where they overlap. And if you look, you'll see that we have blue and green right in the middle. So our actual answer is the intersection of these two regions. So to the right of negative 5 and to the left of negative 3, that shaded region. Not too bad. Let's look at this one. It's a greater than, so absolute value. So we have two equations. So that means we have 2x plus 3y greater than 6. I'm not sure what that thing is. But greater than means or. So this one's going to be, I need some space. Let me just move this out of the way a little bit. We are making a live video. So 2x plus 3y greater than 6, then or, because greater than, 2x plus 3y. This time it's going to be less than negative 6. Now in order to do this, we need to solve both of these for y, so we can graph them on our calculator. So we need to isolate the y. So what I'm going to do is subtract 2x from both sides. We get 3y greater than 6 minus 2x. Notice I don't care how it looks. Divided by 3. So we have y greater than 6 minus 2x over 3. Do the same thing over here. Subtract 2x. We get 3y less than negative 6 minus 2x. Divide both sides by 3. And we get y less than negative 6 minus 2x divided by 3. This is an OR statement. Now what we're going to do is take out our calculator and graph these. I'm going to move the calculator over here so we can see it. Now notice I didn't care too much about how it looks. The only thing I have to remember is when I type in my calculator, use parentheses around the numerator. So here we go. Let's type the first one. 6 minus 2x close parentheses divided by 3. And let's just go ahead and find the greater than. So we don't have to come back to this. So we know we're going to shade above. Let's go to our table and see what we can find. I need points so I can definitely graph. So it looks like 0, 2. And then 3, 0 looks like. Since it's just greater than, dashed line. And above, because it's greater than. I'm going to go to y equals. First off, I'm going to turn that equal sign off. And then I'm going to type in negative 6 minus 2x close parentheses divided by 3. And I'm going to type in or enter until I have less than. Then we'll hit my table. I'm going to use 0 and negative 2. And 3, negative 4. Just want to make sure. 0 and negative 2, 3, negative 4. Dash line again. And let's hit graph again. Below. Since it's an OR, it takes everything that's shaded, so it's going to be all of this and all of this, including the lines. That's what we're doing. Let's do one more. Notice the absolute values and the less than equals to sign. It means we have two equations. We have 4x minus 7y less than equal to 28. Since it's less than, that's an AND. So we'll have 4x minus 7y greater than or equal to negative 28. So once again, I'm going to solve for y. So I'm going to subtract 4x from both sides. And we get negative 7y less than equals to 28 minus 4x. Divide both sides by negative 7. And when we divide by a negative number, we reverse the direction of the inequality sign. So it becomes y greater than or equal to 28 minus 4x divided by negative 7. When I type it in the calculator, I'm going to use parentheses around the numerator. So it's the same process over here. Subtract 4x from both sides. We get negative 7y greater than or equal to negative 28 minus 4x. Divide both sides by negative 7. We know what happens when we divide by negative. The inequality sign is going to change directions. And so we just leave the right side as it is. Just that when we type in the calculator, use parentheses around the numerator. And don't forget, this is an AND. We're looking for an intersection or the overlap. So we're going to take out our calculator. And we're going to type these in. In fact, I'm going to type in both of these at the same time. So let's type in 28 minus 4x inside parentheses, divided by negative 7. I'm going to go ahead and change that to a greater than. I'm going to go ahead and change this one to a less than. Now let's type in this other equation. Parentheses, negative 28 minus 4x, close, divided by negative 7. So the first thing that's going to be graphed is this one, and this is going to be the second one. So well, it looks kind of strange, doesn't it? So that probably tells us that we may need to, well, type it in correctly. You see what I did? I didn't type it in correctly. Make sure you have a negative 7. Now let's graph it. Okay, now it makes more sense. So this top part is what up here for this equation, and then the bottom one, well, let's just see. What's this? I'm going to go to my table. Now what you're going to notice is that we have y1 and y2. Well, this is like my y1, and this is like my y2. You may want to do this. It may be a way to save some space. What I'm doing now, I'm looking at the y1, trying to find a couple of nice points. Okay, I have them. So for the first one, I have 0 and negative 4. And then I also have 7 comma 0. Since it's greater than or equals to, it's equals to, that means that line is included. And if you remember what I said, that was the top part that was shaded. So I'm going to shade the top part. Going to go back to my table. And on this one, I'm looking for a couple of nice points for my y2. There's negative 7, 0. I might have to use my imagination on this one. So there's negative 7, 0. and you know I'm not getting anything that I like. So what I'm going to do is I'm going to hit trace. And watch what I did. Let me do this again. I hit trace, and then I hit up arrow. If I hit up arrow, it changes the equation. I'm at y2. So if I type in like a 1, enter, get a too big, number's way too big. So what I'm going to do is I'm going to hit trace and find a number like -6. See if that's any closer. It's a little bit better. So -6, -7.4, which puts it about right here. And once again, it's less than or equal to. So let's include it. And once again, if I need to, I can always go over here and hit enter and then graph. And you'll see that it's shading to the right. And once again, if I go back to y equals and turn it back on, graph it, you'll see where the darkened place is, and that's my solution. It's everywhere where it's both blue and green. Looks like right in there. Everything above the blue and to the right of the green. So it's the intersection of the two. Sometimes the equations just don't turn out the way you want them to be, but that's okay. Sometimes you have to improvise. So the trace feature can help you out. I knew that -7,0 was a point, and I can use the trace feature and use a number next to it. Just get an approximation. Hopefully all your numbers will be nice and neat.